All right, good morning, Toronto. How's everybody doing? Half enthusiastic? All right. So I hope you guys didn't party too hard last night and that you guys got a good sleep. I know I didn't because I'm very excited for day 2. Yes? No? Okay. All right, so before we get into day 2, let's just recap a little bit about yesterday. So just to give everyone a refresher, and especially those of us joining today for the first time. Yesterday we had 4 main talks. So the first one was Hacking the CXO Code by JP. We had Agent of Change, Here's Your Helmet by Waldo. We've had talks centered around Test Kitchen and Chef and Docker by Arthur. And we've had Will's talk, which was keeping it all together, metrics, logging, and alerting in the code base. So other than that, we also had several Ignites, and we had we actually ran 21 open space sessions, and I walked into most of them actually, and security and chat ups were our 2 most popular ones. It was a really great turnout there. There was like nowhere to sit, so that was really great to see. And maybe we'll just poll the audience to see what was your favorite part of the day. So we'll just have a mic out there, and if anybody wants to pipe up.
Any volunteers? No one? Karaoke was the best one? Really?
Open spaces generally, chat ops especially.
Yeah.
How many for open spaces? Is that the best party yesterday? Hands? Good. So we'll have a lot more sessions with open spaces again today. So
I learned that Dockers makes great shoes. Great shoe company. It's a good one.
boo.
Yeah, I know. Okay, anybody else with any comments on yesterday? How was the party? How did you guys like that? The Ignite karaoke part? Yeah?
No?
No?
Is that a no for next time?
All right. All right, cool. Okay, so let's move on to today. Today we have a fairly similar format. So we have 3 main talks and a metrics panel. And in the afternoon, we're going to have the open space sessions again. So pretty much the same format as we did today. So just a few reminders again, similar to yesterday, just a few logistical issues. So Twitter, you can see our hashtag DevOps days over there. So definitely, tweet things out, and that's kind of the best way to keep track of what's going on, and reach out to your 300 plus fellow audience members. So we actually have a really good number of people who have checked in. We have over 93% of the people who bought a ticket are here, which is really amazing. Other than the Twitter, we have a job board. We have a Twitter wall just outside by the registration desk, and we have a job board, so you guys can check those out again. We also have a live stream going today, similar to yesterday. So please send that out as well. Email that to your colleagues who are at the office right now. So distract them. That's what DevOps is all about. Just a few other logistical issues, again, similar to yesterday. Again, you can go to the registration desk at any time if you have any questions, or you can tweet the organizers if there's anything that we can do to help you. And the Wi-Fi password's up on the screen there in the slides. And lastly, just the code of conduct. So again, very important. That's the checkbox that you guys checked when you bought the tickets. So we want to make sure that everyone has a safe and happy environment, and that they can communicate with everybody else. So if you're not familiar with that, check out the code of conduct on the site. And I think that's about it. So just one last thing, if Will Weaver's in the audience, coming up to the backstage. So I think that's it. So now we're going to move on to our first speaker. So we're going to be talking about using continuous integration to test your platform. So everybody please welcome Kirsten Hunter.
I'm not her, I'm just stalling.
I won't entertain you with any more Dockers jokes, I promise.
Come on, a round of applause for no more doctor jokes.
Abuse. Stick two is done, John.
Sweet. All right, let me test something. I'm actually going to attempt to use my watch, my cool Apple Watch, to run the stuff, so y'all can laugh if it doesn't work, and I'll just use the buttons like everyone else. And if it does work, then the world is good. It's going to be difficult. So, hey, I figured if I couldn't get it working in like in a couple seconds, it was not worth doing. So I'm going to be talking about testing your platform using continuous integration tools. I'm going to be talking about using Jenkins, but you can use anything else. In a DevOps world, there's actually things other than platforms that you guys have to rely on. Systems that are integral to your processes, things that may or may not be up constantly. And if you have something that runs, for instance, once a month to do some reporting for you, and you don't find out until the once a month that it's not working anymore, it makes your life miserable. So I'm an API evangelist. I don't own the APIs themselves. Our development teams, of course, own the APIs. However, I am in charge of the example code, and I feel that it is critically important that when a developer downloads the code from GitHub, that code runs correctly. So as somebody who is working as an API evangelist, it's critical to me that I have a way to test that the APIs continue to work with my example code. However, I can't set up some kind of weird testing framework because I want to directly test exactly what it is. So my presentation style, you'll notice there's not a lot of words on my slides. That's because I found that if I put a lot of words on the slides, then I rehearse, and I read you the slides, and you read the slides, then it's like story time, and everybody goes to sleep. So no story time. I'm just going to talk. I do have the code that I have that's pretty simple. I'm mostly talking about strategies here on GitHub, and it's totally findable, so you don't have to worry about it. And there wouldn't be any really useful notes anyways, because I always say what I do is like an interpretive dance. So who am I? I'm Kirsten Hunter. I've been working with REST APIs for 10 years. I used to be a system administrator at Silicon Graphics. I was a software engineer. I did a lot of stuff with SCM tools. I've worked at all across the organizations in support, in operations, and in development. My website is princesspolymath.com. My Twitter handle is Sinedra, and it's findable from the thing. And if you guys tweet things that I say, I will give you a bottle opener if you come up to me afterwards. I was going to throw little like T-shirts and stuff at you guys, but these is too close together, and the bottle openers are metal, and it might have hurt you. So I thought that probably wasn't the best idea, so I didn't go with that. So as I said, this talk is about integration testing. I'm using Jenkins. Don't have to use Jenkins. You can use anything. I want you guys to think a little bit about some things that you might be doing with cron, where you could get better output if you use a system that has a better framework for reporting. One of the problems with cron is it sends you email. If you send email to your NOC, they don't pay attention to it, and it's not really that useful. And you want to be able to show trends. Gosh, the system that we rely on is down 20% of the time. That really sucks. So having the ability to do this reporting is really important. Java. Okay, yeah. No. I'm not talking about using Java with Jenkins. I know it was made for Java. I don't like Java. Sorry. So I actually sort of shot myself in the foot when I was trying to put this together, because I sort of had a hissy fit, and I went through and I disabled the Ant and the Maven and all of the Java things in Jenkins, and then I discovered that JUnit was one of the things that I had disabled. which actually caused it not to work. So what about unit tests? What's the problem with using unit tests? Almost every language, just so you know, has good unit test framework integration with Jenkins, and it'll spit out JUnit for you, and then you can use the reporting capabilities of Jenkins. But that's what everyone does with Jenkins. And I'm talking about testing my example code. If I made unit tests, I would be testing the unit test. I would have duplicate code in 2 different places, and I wouldn't be testing what it is that I want to work. So what do you need to make this work? Well, it's pretty easy to get Jenkins to run scripts. You've probably done it before if you have worked with Jenkins. Jenkins is open source, same as Hudson. It likes JUnit. And the problem with JUnit, that's the spec for JUnit. It's a little overwhelming. I took a look at it and I was like, whoa, I gotta put it together. This is awful. Okay, that's actually what you need. That's not so awful. It's much, much better. So the minimum requirements are for you to define what the tests are, how many tests you have, what the class names are, and then stick failures in there if you have failures. That's all Jenkins really needs in order to make the graphs that are decently useful. So I'm going to talk a little bit again about what you guys might be wanting to test. So in operations, you frequently have to rely on APIs that other people own that are not as consistent as they might be. One of the things I talk about elsewhere is irresistible APIs. I talk about how to make irresistible APIs. And the reason people listen to me talk about irresistible APIs is because most of the APIs out there are pretty resistible. But you have to use them. You need them. You're trying to integrate with the system. And if the integration with the system is critical to your success, then you need to make sure that that system continues to work the way you expect. So this is going to test a couple things. It's going to make sure, hey, is the API working? Is it up? Is it returning errors? Do I need to change my code to watch for these particular behaviors that are bad? Or do I need to tell the people who own the API that it's not consistent? Do I need to retry? What do I need to do? So whatever systems that you're dealing with, even if it's just pinging a system to make sure it's up, even if it's running a PS to make sure the processes aren't running forever, having an external process like Jenkins that goes and does this stuff for you and comes back makes it possible for you to test the stuff that's critical to your job all the time without having to get surprised, unfortunately, when things don't go well. So this is a pretty simple Python script. It's not easy to see, I understand. The code is on GitHub, I promise. It's actually, I work for Akamai, and we have an API Kickstart repository, and this lives in that repository. At Akamai, we had this problem where some of our APIs, especially the beta ones, were having inconsistency issues, or they weren't working the way that our customers were expecting. And when example code doesn't work, you have grumpy developers, which is not my goal. My goal is to make our developers really happy, and your goal is probably to make yourselves avoid unexpected things happening at 3 o'clock in the morning when you're trying to do the sleeping thing. So this code shows at the top what it is that you need. And I didn't even use an XML library. I made this is the most rudimentary thing I could possibly come up with to create a JUnit file. It just spits out a thing that says, this is the test case, and if there's a failure, it takes the error from standard error, and it throws it into the JUnit, and And Jenkins is perfectly happy with this output. So the feature in Jenkins that we're using, keep talking about JUnit, and JUnit is it's an ant function where it creates different, when the builds happen in Java, it can spit out these test results, and that's what Jenkins was designed to use. So basically, I'm kind of convincing Jenkins to do things that it really wasn't intended to do. When you set it up, you're going to have build steps. And the way I decided to deal with this particular problem was to change my code, first of all, so that it had really good error handling, because without really good error handling, there wasn't going to be any way for Jenkins to figure out whether something went wrong or not. And so I send the output for the command to standard out, put that in standard output, and then I put the errors to standard error, and then I redirect those to output and errors. And then I made the little JUnit thing that generated the JUnit file from the output and errors. And basically it says, if there's an error, make a JUnit file that has an error. Otherwise, just make a JUnit file that describes what this is so that it can go into the Jenkins dashboard. When you do this, my little JUnit thing, and I'm telling you that you guys are smart enough to figure out a way using Bash or whatever. You don't have to use MyPython. It's just an example of what you can do. You can use whatever you need to use to spit out this little text file. You put it wherever you want it to put it, and you tell Jenkins the URL, the path that the XML lives at is this path right here. So don't despair. You can't read code on a slide. It's just not a thing. The code itself is on GitHub. The code lives in the repository that's API Kickstart for Akamai. If any of you are Akamai customers, it's also got cool stuff for using our new open APIs. But I always put stuff on GitHub to make sure that people can practice with the things that I have. Also, I want to invite you to ask any questions of me that you might have, because I'm an evangelist. I'm an API evangelist. My job is to help people. I go to these talks. I want people to send me, you can send me tweets, and I will get back to you. I will tell you what it is that I've done. I'm happy to answer any questions about APIs, but and I know that a lot of you have to deal with systems, like I said, with APIs that are inconsistent or that change, right? So it's not always the system is not working correctly. Sometimes the problem is that the system has evolved and they put out a new version. They don't tell you, they fix some bugs, but one of those bugs you were relying on. The support that you were doing was the behavior you were relying on was not actually the behavior that the API people expected you to use. They didn't actually tell you in the documentation how they expected you to use it. And so you relied on this field being in this format. And they were like, oh, hey, that's a number, shouldn't be a string. So they changed it from a number to a string to a number, and now all of a sudden your code doesn't work. So you guys need to be aware when you're using other people's systems. I mean, I'm sure that most of you are quite aware. When you're using other people's systems, you are in a situation where you need to code super defensively. And that's whether you're writing a script, or whether you're writing code, or whether whatever you're doing. So I think I have finished early, super early, but I started really early. So let's have some questions. What kind of things do you guys test? What do you need? What is it that you're trying to integrate with where you have problems? As a sysadmin for 15 years, I had a lot of experience with systems that didn't work correctly. So
I'm actually fascinated by this because this almost exactly describes my internal problem space, which is my team being a bunch of Ruby developers for a specific project, working with an internal API that is developed in Java by another team who are using Jenkins for continuous integration, very much into making us do, if they can, everything through Jenkins. So the idea that I can trick Jenkins into letting me use RSpec for my integration tests as part of a continuous integration pipeline is great. I'm curious, I guess there's not a huge amount of difference if you're dealing with something internally developed rather than externally developed.
No, Jenkins will do any kind of scripting. It actually has plugins for Ruby and Python, but I found that those are not as useful as just telling it. I mean,
Faking it with our unit.
I just told it, you know, go to the correct directory, run it using the correct Python that I want. I don't want the Python that Jenkins thinks it wants. I want to know exactly what's going to happen, so I can reproduce exactly the same system. So Ruby does have a continuous integration library, but that integrates with Jenkins. However, the only problem is that, once again, it expects unit tests and not after the fact user testing, which is what we're talking about here.
Yeah, and that's, I don't have a mic, but I'm very loud, and that's exactly our testing, but actually having something, like what we need is kind of a contractual test layer with our other internal group where it's like your API is continuing to behave
Right.
as we expect.
It's integration testing from the user side. You know, unit tests are great if you own the code, but as soon as you don't own the code, or even if somebody you know owns the code, it's still nice to say, well, what would a user do? And you are consumers of this system. So that's one of the things that can happen. We have a question here.
So how often exactly do you run your test cases? Is it something that you have automated where it runs on a daily basis, or do you only do...
So Jenkins allows you to tell it how often you want it to run. You can tell it to run periodically. You can tell it to run every time. So if you are only testing to make sure that your GitHub repository is still safe with all of the things, so you change the library or whatever, and you want to make sure that that's good, you can tell it every time a commit is made to GitHub, it should run. But I run it hourly. It's tiny. It doesn't take up a lot of space. You can tell it not to keep the logs that long. And it makes me feel better. Because if as soon as our API changes and the code breaks, 10 developers are going to download the GitHub repository, and they're going to be very, very cranky. So I try to avoid that wherever possible.
You described your role as being an API evangelist. One thing that I'm curious about is what is your team doing to write and maintain sufficient documentation for a public consumer of your APIs?
Oh, we use Blueprint, actually. We require that our API, that all teams that are doing development work with the API architecture team. And so they have to make a functional specification, and along with that functional specification, they have to make a blueprint, which is a schema modeling system. And in order to force them to do that, they cannot deploy APIs unless they have a blueprint. Blueprint is what actually drives the deployment of the APIs out to the world. So that also drives the documentation. I can show you what I think the documentation work looks like. I know it's a little off topic, but it's all good. All right, let's see. Oh, yay, it wasn't anything embarrassing. That's awesome. Okay. If you want to see great documentation, Twitter actually has fantastic API documentation. They are my favorite. But we actually, so a couple of the things that we do, we listen to our customers. Our customers actually said, hey, the documentation is really crappy and I don't know how to get started. And so we said, well, okay, let's fix that. So you'll see, first of all, one of the things that's critically important is getting started, how to use the API. API reference documentation is only helpful once you already know how to make the calls. So we have the introduction section, which is the same as the get started button, which is the same as the introduction section at the top. We want people to be able to find their way there. But the API documentation itself, we'll look at a pretty simple one. So we have an overview, which talks about stuff. We have very simple overview for diagnostic tools, which is basically DIG and MTR. It's a fascinating API, but look at this, we're not having any demo daemons. Well, we did with the watch, but that's okay. So this actually tells you, what the right parameters are, what the required parameters are, what the non-required parameters are. On the more complicated things, it'll tell you what the post needs to have. But more importantly, over here, and it's hard to see, but it tells you what, in this case, it's a get, and it tells you what response you can expect, right? So good documentation makes it so that the developer knows, or the operations person, whoever's using the API, knows exactly what they need to do to get exactly what they want. So that's the answer to that. Does that answer the question? Yes, more questions. Oh, come on, guys. You don't want me to ask questions.
Super simple, and loud mic too. A super simple question. I just came across this last week, actually, a doc test. I don't know if you've worked with it, but the concept is you format your documentation in Python in a certain way, and then you can run a test runner against your documentation, and it'll say, does the example code work? Have you worked with that?
I haven't worked with it, but I know a lot of people who have worked well with it. One of the things that's fantastic about schema modeling, and here's something that is probably useful for all of you who are trying to automate against other people's APIs. If people do use schema modeling systems such as Ramble or Blueprint or Swagger, you can actually use that document, if you can get a hold of it, to automate testing of the documentation, but also testing of the system itself. Even, you can make sure that everything works exactly as it's supposed to work according to the specification, and that's going to make sure that you can have confidence that when you run the other things, they're going to work correctly. So that's another way that you can test someone else's system and not have to worry about it. Any other questions? I know you guys have questions. Yes. There's one over here. The guy with the awesome hair.
How well would this work against something in production? Like typically we would use, like not for API checks, but for like an actual system check. So your originating argument was for like a system you run once a month, like a reporting system. Like off the top of my head, I would use something like Rundeck to execute against something live in production.
Right.
Not typically something like Jenkins. So I can see the advantage of Jenkins being you get like continuous history and you get the reports and everything. But would you typically deploy something like Jenkins against a production environment?
So I am testing production code. I'm testing our APIs that are in production, but I do understand that there are situations where you don't want the same thing to happen every time you test it as what happens when you really run it. What I would do in that case is I would actually change it slightly so that there's a read-only version that just pulls all of the information and doesn't write whatever the thing is to the system that it's supposed to write it to. If you are trying to test the writes, it's much more challenging because you don't want to put test data in a production database. But usually if a system is still working on the read side, it's going to be working on the write side. So it is a much more challenging situation, and the test code that I test does not actually write to our systems. It does all reads. But usually when one of them goes down or changes drastically, it's on the read side and not on the write side. But example code that writes to the APIs is not a great idea. I try to avoid it. Any other questions? Questions about APIs in general? Questions about testing in general? There's one over there.
How do you feel about technologies that?
Oh, go ahead.
Yeah. How do you feel about technologies that take a spec and generate code, like that would generate your handlers and stuff like that?
I actually think that that's reasonably good when the spec is good. I think you can't completely rely on it, but I think that you can. I think it's better to take the spec and use it to verify that the code is doing what it's supposed to be doing. There's a reason we have developers. You know, a product manager could make a spec, and then theoretically they could create an API or a system. And I'm guessing that the code generator wouldn't be as good as a person whose job it is to understand the edge cases and to actually meet the use cases that are out there. So I have mixed feelings about them. I think they're kind of cool. I think they're nice to start with. But I think that a person has to be involved in the process. So there was a question over there.
Do you have any experience with a caching proxy in front of a problematic API?
I do not have experience with a caching proxy. I will tell you that we have a proxy at Akamai. If you can't actually, well, we don't have a proxy. We have proxy prevention. It uses HTTPS, and if you try to use something like Fiddler, you can't actually watch our code. Fiddler is a great way to test APIs because you can see what the transactions are. But our APIs are designed so that if you're coming through a proxy, it doesn't work. But on the other side, I haven't worked with caching proxies. I am certain that our APIs are cached, however, because I work for Akamai. So while I'm not completely familiar with the whole infrastructure, I can't imagine that we don't do that. You guys are awesome. You're helping me out.
Hey, so you just showed us Blueprint. I haven't used Blueprint myself, but we use Swagger, and I was wondering if you compared the two. Because for Swagger, I like how you can actually do the get, post, whatever request from within the
Swagger is getting better at those sorts of things, generating a little console. The apiary actually, so apiary is the blueprint maker and owner, and they actually allow you to do some mock server behavior. Unfortunately, it doesn't work for us because we have custom authentication, but you can actually make mock calls to the server if you have a standard authentication protocol. I like Swagger personally. If I got to choose, I would use Swagger, but that's because I think Markdown is ugly and JSON is beautiful. So I think all three, RAML, Swagger, and Blueprint, are doing a fantastic job of keeping up with each other. For a long time, Apiary was the only one who made it super easy to generate the specs and sort of just play around with it and create your little API. And nobody else had tools to do it, but now Swagger has them, and MuleSoft has made RAML have them. So if you guys aren't familiar with, or schema modeling, you might be familiar with SOAP APIs, and they have WSDL. And so WSDL basically is the contract that says this is what you're going to get when you call this particular thing. And REST APIs don't require any kind of schema modeling, which is one of the reasons that they are not irresistible in most cases. However, once there is schema modeling, you can see it expresses what you can expect from the API. And all of the schema modeling systems were designed to generate what I showed you here, reference documentation for the APIs. So when people are using those schema modeling systems, it ends up being much better for the users and for the developers. Because who wants to develop something and then have to change it? Any other questions?
Man, I have another question.
Oh, okay, cool.
So what about, this isn't a problem that we face personally on our team, but what about testing APIs that depend on systems that you don't control, or that you can't like roll back? For example, like a credit card transaction processor. You depend on it, but you can't just go and undo that transaction. You
Right.
just did.
Well, in a lot of cases, what you're going to do when that API fails is you're going to tell the people that it didn't work. One of the things that you can do when you're bootstrapping this sort of thing is you can say, hey, if it fails, open a case through the API with these people that has these parameters and tells them that their system is broken in these particular ways. So that's the ideal situation, is that you need to spend a minimum amount of time dealing with, hey, the back-end system is throwing errors, I'm getting 500s. As soon as you get a 500, you know the API is not useful to you anymore. So you may need to retry, you may need to change the way your systems work, but this will tell you. If something happens more than one time, you're probably going to want to be able to error catch that, or go, cube sit. Yeah, I mean, basically at that point it's a black box. But cube sitting is an excellent way to get developers to do things. I refer to it as cube sitting. Operations people actually, this is a fantastic idea. Take your lunch, go to their cube, sit in it, and just tell them, that's cool. I'm just going to hang out here until you get to my thing. It's all good. But you gotta get in their space, and but be quiet. Don't be rude. I mean, this is Canada, so we're not rude. You can just go and you can just sort of hover quietly and politely until they address the issue that you've got, because it's blocking you, right? You can no longer do your job, so they need to fix it. And they probably have a bunch of other people who wanted things, or they have stuff they want to work on. So, all right, are we good?
All right, round of applause for Kirsten.
Thanks so much.